Welcome back. Math 10s, Mr. Tronis here. We are going to dive into 2.6, factoring trinomials. So recall, when we are factoring, that just means breaking polynomials, in this case, apart into its pieces. The pieces are called factors. Factors are things we multiply together and we can get back to the same polynomial. And many trinomials, can be factored into the product of two binomials. So it's going to look something like this. So let's verify this first statement. We got a trinomial, and we want to verify that it can be factored into these two binomials. So I'm going to do this a tiny bit differently. So recall, I would take this x and I would multiply it by each of the terms in the second binomial. So I'm going to write it a little bit differently. Now, you never did this before because this was a long way of doing it, but I'm taking this x and I'm multiplying it by the set of brackets. And then I'm taking the -7 and I'm multiplying it by the same set of brackets. Okay, this will become important shortly. Next, we're going to multiply this all in. And we know how to do this. X times x is x squared. X times 2 is 2x. And -7 times x is -7x. And -7 times +2 is -14. And then, of course, we get our like terms in the middle here. We're going to combine them. +2 and -7 is going to give me -5x. And then let's bring down our constant of 14 and the x squared. And we see we get right back to how we started this off. Now, what we're going to learn now, and I know it looks like a lot of words down below, and we're just going to reference that from time to time, is how do I go back? How do I start with a trinomial and basically make these steps to get back to the two binomials? Okay. And each of these steps are not that challenging, actually, but we need to get used to this process. Okay. It's very much an algorithmic way of doing things. So we need to follow it step by step. So the first step here, we're actually going to ignore. We always do want to check for a GCF first, and we will explore that more in the next lesson. But to keep things a little more simple, we will not have any GCFs yet. Okay. But just to show in this very first example, my leading coefficient here is a 1. And as soon as we have a 1, I know I can't take out any numbers. I can't find a GCF other than 1. And there's only, there's 2 x's here, 1 x here, but no x's here. So I can't factor out an x. So there is no GCF. Now, we then are going to be looking at trinomials of this form, ax squared plus bx plus c. Okay, this is a fancy name, and you'll learn in pre-cal 11 if you take that course, called a quadratic. And these can do some really cool things with applications. But really, what we're learning in Math 10 is how do we handle these things before we learn how to use them in the real world. Okay, so we always will have three numbers, a, b, and c. And there'll be some variable. It won't always be x. It could be k, m, z, doesn't matter. Okay, so let's work through these steps. We're going to start with this step 2. And this step 2 we are doing for a very unique reason. We are going to first take the first coefficient of 1 and multiply it by the last number, the a times the c in our equation, okay, the 14, and find out what that equals. Well, that's easy. 1 times 14 is 14. Okay. And now what we're going to do with this number is something very unique. Okay. We're going to find two numbers that multiply to give us 14. Okay. While simultaneously finding those two numbers that are the same that also add to our middle coefficient, the +9. So we need two numbers that multiply to 14 while simultaneously adding to 9. Now, I know some of you might already say, well, that's 2 times 7 and 2 plus 7, Tronis. I got it figured out. And we're starting with a pretty straightforward one. But why are we doing this? Well, if we look back above, if we were to work backwards, notice that the two numbers up here, the -7 and the 2, multiplied to give me -14. And those same two numbers appeared here to give us the two like terms that gave me a sum 2 plus -7 I could say, to give me -5. So that's where they're actually coming from. I'm not just pulling it out of a hat. Now we do a simple t-chart for this. We take the number that we are multiplying and we do a product. Okay, so we want to find all the pairs that multiply to give me 14. Well, we have 1 times 14. Always start with the easiest, but remember with integers, there's always going to be another version, which is -1 times -14. Now, neither of these add to give me 9. 1 plus 14 is 15, -1 plus -14 is -15. So let's try our next pair of factors, which is 2 times 7 gives me 14. Well, if I add those up, I get +9. So we're going to stop, but just for reference, there would be one more pair of factors, okay? And we actually give this a bit of a cheesy name. It is very unofficial, but these two numbers, okay, that we find are called, or we're going to call them magic numbers, okay? These magic numbers are magic because they do two things at once, okay? The 2 times the 7 gives me 14, and the 2 plus the 7 gives me 9. Now, our next step, what we've just done, sorry, is step 2. We multiplied, okay? And we found those numbers that added and subtracted. That's what's being stated in here. I'm not going to read it all out. We're going to move on to step 3. We're going to use those magic numbers to decompose or break apart our middle term, the bx, in this case, the 9x. So we're going to break it apart into 2x plus 7x. Now we know we could go right back to the 9x if we wanted to, but that's not our intention. Copy down the other two terms that we didn't touch, the x squared plus the 14, and we're done step 3. Now, step 4 is another unique thing because we're used to factoring an entire polynomial. But when we're doing this, our intention is to factor these as two separate binomials currently. Okay, we have 4 terms. I'm going to factor the first 2 terms, then I'm going to factor the last 2 terms separately. So let's do that. X squared plus 2x, my GCF is just x, leaving me with x plus 2. And in my second 2 terms, I'm going to have 7 is my GCF. So I'm going to factor out a 7 because 7 divides 7x and 14. And I'm left with x plus 2. Now you're going to notice something. Well, I got x plus 2 twice. That is a good thing, and you should be happy when you see it. So here and here, if you get, okay, if we get identical brackets, okay, you are good to go, okay? That's a good thing. If they're not identical, we can't do our next step, which says after we've factored that, we're going to factor one more time and we're going to factor the actual set of brackets. Because remember, these are identical. These are two terms, x times a thing plus 7 times a thing. The thing is identical, the x plus 2. So let's factor that out, the x plus 2, and let's write our leftovers, which was the x and the 7. Okay. And sometimes your order might change. So just remember, this is not wrong. This is perfectly correct. The order and how you write your binomials does not change your answer. And this is our first trinomial being factored to two binomials as a product. All right, that was a long process. We went really slow. So let's speed it up and try some more. All right, so first step, let's see. First, we need to multiply our A and our C, which is 1 times 9 gives me 9. Let's now find two numbers that multiply to give me 9, while simultaneously sum to give me the middle coefficient, which is -6. Let's make our chart. So 9, its factors are 1 times 9. That doesn't work. 1 plus 9 is 10. And -1 times -9. That doesn't work either because that'll give me -10. Let's try 3 times 3. That's going to give me 9. But when I sum that, I get +6. So it's actually our last one this time. Here's our magic numbers. We found them to be -3 times -3 is going to work. And -3 plus -3 is going to give me -6. So here is our magic numbers right here. We're going to decompose now using those magic numbers. So the -6x turns into -3x minus 3x. Broke it into the two terms. Let's bring down our remaining two terms. Now we have a 4-term polynomial, and we're going to again factor the first two, then the second two separately. When we do that, my GCF of my first two is x. So I get x minus 3. And now careful here, because my leading term of these two is negative, we're going to factor out the negative. That's important, because if I don't, my brackets won't match. So if I take out the -3, I'm going to be left with, because 3 divides 9, I'm going to be left with positive x minus 3, because -3 times -3 gives me positive 9. And now finally, we can do our final factoring. Let's factor the common pair of brackets out, and my leftovers is also the same thing. I get an x minus 3. Now that's not wrong. It just happened to work out. This actually has a special name because we can represent it as a perfect square. Remember, a perfect square is anything that can be broken into two equal factors. So I'll just add a little side note to this. This is called a perfect square trinomial, is what we started with, trinomial. Put a little arrow because that's what we started with, because I ended up with, once I factored it, the same factor being multiplied twice. Okay? All right, let's try one where the first coefficient is not 1. It's a 4 this time. So now a times c, remember 4 times the 3 is going to give me 12. 4 times 3 equals 12. So the magic number process is the same now. We're going to find two numbers that multiply to give me positive 12 while simultaneously adding to give me the middle coefficient of negative 13. So let's draw our t-chart of our factors. 1 times 12 is our first pair. Add those up, I get positive 13. I'm going to do the negative version, and we're done already. There's my magic numbers. There's many more factors, but don't keep going if you don't have to. So I'm going to use -1, -12, and -1 and -12 are going to both work as my magic numbers. So let's move on to decomposition. -1k, -12k, bring down my last term and my first term. And now we're going to factor them as two separate factors, or sorry, two separate pairs. So in my first set here, I'm going to factor out a k, leaving me with just 4k minus 1. In my second here, now remember, I have a leading negative. Okay, so that my greatest common factor is 3, but I'm going to take out -3. And that's going to leave me with 4k minus 1, because -3 times -1 gives me positive 3. My brackets match, so I can feel good. I'm good to go. I factor out the bracket portion, and I write my leftovers, which is k minus 3. Again, multiply it all out to verify, and you know you got the correct answer. Two more to go, folks. So again, we have a 1 this time, so I'm going to multiply these two, but careful, don't forget the sign. This is a -12, so this is 1 times -12, which gives me -12. So now let's do our magic numbers. Two numbers that multiply to give me -12 while simultaneously summing to give me the middle term, which here, oh, I don't know how that happened. Okay, I got it back. -1 is my b value, my coefficient of the middle term. So I need them to equal -1. Okay, so let's dive into this. -12, let's break it into its pairs of factors. We have first 1 times, and this one of them has to be negative, so I'm going to write this as 1 times -12. And then there's the opposite, where -1 times positive 12. Okay, neither of those add to give me -1. Let's move on. There is 2 times -6 and -2 times positive 6. Neither of those work. Let's try another one. The last pair, actually, 3 times -4. If I add those up, I get -1. So let's stop there. There is one more, but that's enough to get us our magic numbers. It's right here. So I'm going to go 3 times -4 to give me -12. 3 plus -4 gives me -1. Let's decompose the middle term. So we get positive 3x minus 4x is how we break it apart. Let's bring down my other terms. And let's factor each pair. Again, I'm going to factor an x here, leaving me with x plus 3. Leading coefficient's negative, so let's factor out a -4 is my GCF with an x plus 3. And now let's factor our brackets out, x plus 3 times x minus 4, and we are done. All right, last one. Okay, 4 times -6 is going to give me -24. So again, let's find two numbers that multiply to give me -24 while simultaneously summing, adding up to give me +5. Now you might be getting better at this and you can see it right away what those two numbers might be. And some of you might just need to work through this step by step. So we get 1 times -24. That doesn't work. That equals -23. -1 times 24. That doesn't work either. We'll try 2 times -12. That doesn't work. That equals -10. -2 times 12 equals +10. I hope you start to see the pattern of where I can skip and not check some of these things. Next one is 3 times -8. That doesn't work. That's -5. So I'm pretty sure I'm close here. -3 times 8. Yep, we're good to go. That equals +5. So I have discovered our magic numbers here. Let's plug them in just to double check, make sure we didn't make any silly mistakes. And yes, -3 plus 8 is going to give me +5. Let's decompose. So -3x plus 8x. My first term, bring it down. My last term, the constant, bring that down. And let's factor them. In this one, again, all I can take out is an x, which is very common. And I'm going to be left with 4x minus 3. And in my second 8x minus 6, the most I can divide out is a 2. So I'm going to take out a 2, and I'm left with 4x minus 3 again. I get matching brackets. We are good to go. So I get 4x minus 3 times the leftovers, which is the x plus the 2, and we're all done. All right, so that was a big lesson. All right, this is not easy at first, but once you work through this process, you have a fair chunk of practice to go through. It is the same algorithmic steps every time, and you're going to be just fine. It's going to go real easy with a little bit of practice. Okay, we'll see you in class.